So in the last video for the Chapter 14 review, I want to take, equations that we've already worked with and come at the calculation in a different pattern. And in the process, actually rearrange the pH equation just a tad. Okay, so I want to do the second one here. And I want to go from pH to the hydroxide concentration. Now, I will say that if you were looking at the pOH portion of the textbook, you can go that route and do the calculation that way. I'm choosing not to do that. What I'm choosing to do is actually go through hydronium concentration first. Now, first off, this last little bit here, we've seen that type of calculation before. For this last step, we're going to use that kW expression, 10 to the minus 14. I'll rewrite this more clearly in a minute. The only equation that we've seen relating the hydronium and the pH together was this one. Okay, so I have the two variables or two data points in an expression. Instead of showing pH equal to something, if we rearrange this to make hydronium equal to something, well, one form of it is this. So this is the equation we're going to use for this step here. And then just sort of cover all my bases. Sometimes the 10 raised to the minus blah 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 here, you see anti-log of the minus pH. What that really represents is the second function of the log key on your calculator. But again, I'm going to choose to do it this way. And that's going to be our first step because that's the data point that's given to us. Let's plug into this formula here. So 10 raised to the minus pH, what is that going to look like? It's going to look like this. On your calculator, what you're going to do is 10, and then there's a variety of buttons that will do this. A lot of the Texas Instrument calculators uses this little caret. If you do this math, you get a hydronium concentration of 2.2 times 10 to the minus 4 molar. Again, you can also do this, instead of using the caret or the raised to button on your calculator, you can also use the second functional log, which is known as the anti-log. And now that I have hydronium concentration here, then I can rearrange this expression to solve for hydroxide. Just like I did on the last problem, if I divide both sides now, in this case by hydronium, I get my new expression. It cancels out. My new expression is this. I'll plug this value in for hydronium. I get a value of 4.6 times 10 to the minus 11 molar. And with that, that covers most of the calculations that you're responsible for the Chapter 14 material. Okay, thanks.